Geometry, we are cruising through our first unit on roots and radicals and simplifying expressions, all that sort of stuff. Yes. And so we're going to start with something we've talked about before, which are other degrees of roots. The reason why when we do a 5-card challenge and you use a root, you need a 2. Like if you want to do the square root of 9 to get 3, you need a 2 there, is because it is a square root, and technically, did my thing fall into the thing on the floor? The magnet thing? Oh, you put it on there, please? Technically, a square root means what number squared, what number times itself, and that's how we get 3 here. We don't write the 2 because the square root is so common. Okay, that if there's no number, it's assumed it's a 2. But there are other types of root, cubed roots, fourth roots, etc. Okay, what this means here, the cubed root of 8, is what number times itself, or what number cubed equals 8. Well, that be 2, right? 2 times 2 times 2 is 8, so the cubed root of 8 equals 2. Okay, the fourth root of 81 means what number times itself, times itself, times itself. What number to the fourth power is 81? 3. Right? 3 times 3 times 3 times 3. The fourth root of 81 is 3.
So we do it like that?
Here we have the cubed root of 64. What number cubed equals 64? 4. So this would be 4. Okay. The eighth root of 1. What number to the 8th power equals 1? 1 does. And then the 5th root of 100,000, what number to the 5th power is 100,000? 10. Okay? So that's how you read other degrees of roots. Okay? Usually when you got a square root, you don't see the 2. Like I said, it's not written, but it's there. But it means what number squared equals 9. If you're dealing with other degrees, you're taking that root to the 5th power, the 4th power, or whatever.
Wait, how did you get 2 for the first one?
Because 2 cubed, 2 times 2 times 2 equals 8.
No.
2 times 2 is 4, and then times 2 equals 8. Okay? James?
Is it true that D's get degrees?
I've heard C's get degrees,
But D works better because it's a D.
whatever works for you, man. Evan?
What about, so the
I just
number
thought it
on
was
the left is just how many multiplication?
Yeah, the number on the left is basically saying, what number to the 5th power equals 100,000 is how you could kind of think about that. And that's where you get 10. 10 to the 5th power is 100,000. Here it would be what number cubed equals 64, right? And that's where 4 comes from. 4 cubed equals 64. Similar to how you think about this. What number squared equals 9? 3 squared. This would be what number cubed? 2 cubed. 2 times 2 times 2. And so on and so forth. Okay? And it's that idea, dealing with other degrees, that launch us into fraction powers. It says the different degrees of roots are important because they're used to simplify fractional powers. Yes, exponents can be fractions also. And when you get a fractional power, it is best to rewrite it as a root to evaluate it. Here is an example. This goes on a help sheet because this tells you where all the pieces go. Any base to the x over y power, right? You got a fraction there. X is the numerator, y is the denominator. Any base to the x over y power that's equal to that base, the degree of the root is the denominator. You're taking that whole total to the power of the numerator. Okay? It'll make more sense once you plug numbers in there, I hope. Okay? This is the basic formula. This right here, what I boxed, should go on a help sheet. That explains when you have a fractional power where the pieces go. So for example, 8 to the 2/3 power, here is our n to the x over y. We have a base of 8, right? And we have a fractional power, x over y, 2 over 3. We can rewrite that using a root And just take a moment to notice where each piece goes. Where does the 8 go?
The
Our
egg
base
into
goes under the root.
parentheses.
Shh, I wasn't asking you. The base goes under the root. The denominator becomes the degree of the root, and the numerator becomes the power to which you take that total. So 8 to the 2/3 power is the same as the cube root of 8 squared. Nothing else gets added to it. No other numbers, nothing else. It's just where can we rearrange these things to get something that we can actually evaluate. Now,
Okay.
are there questions on how we get from here to here? You see where the 8 goes, you see where the 2 goes, you see where the 3 goes, okay? That follows this pattern here, right? The base becomes the base of the root. The denominator becomes the degree of the root, just like we did here. 3 became the degree of the root. And then the numerator becomes the exponent to which you take that total, the 2, we ended up squaring the cube root of 8. Okay? Now, where I got this 2 from is the cube root of 8. What does that equal? 2, right? I just simplified what was in the parentheses. The cube root of 8 equals 2.
Okay.
And then that becomes 2 squared, which is 4. Okay?
So the first one is 5.
Where I get pushback, Evan, Luca, where I get pushback from folks on E and R being opposites is that you can rewrite an exponent as a root and a root as an exponent, which we can see here. You can do it with square roots also, okay? My argument is that you can also write division as multiplication, right? If we take 8 divided by 4, that is the same as 8 times 1/4, right? You can rewrite the operations as each other because they are opposites. But if you ever get pushback on why the R shouldn't be there, because exponents and roots can be rewritten as each other, this is the argument that's made right here. Anyway, rewrite the term using a radical, then simplify it. 25 to the 1/2 power. Where does this 25 go?
In the parentheses.
In the root. What's the degree of this root?
2.
2. The denominator becomes the degree. This total is taken to the power of 1, which is the numerator of the fraction. The same 3 numbers that are here are the same 3 numbers that show up here. It's just where do I put them? Okay? Now we can simplify this here. What's the square root of 25? 5.
So what page?
And 5 to the first power equals 5.
So I was
Okay.
right.
Yes, you were. 81 to the 4/3 power. What goes under our root?
81.
81. What's the degree of the root?
4.
4. All that is being taken to the
3rd.
3rd power.
3.
Do we see how this works?
Yes.
Okay? Now what is the 4th root of 81? Or what number to the 4th power equals 81? 3. So 3 goes in our parentheses. That's cubed now, right? Because we didn't use this power out here. 3 cubed equals 27. Right?
It's finished.
Now here's how some of you might be able to look at this, right? If this was, look at this. If this was 81 to the 4/4 power, that'd be the same as 81 to the 1st power, right? Which is 81. Okay? When we're looking at this, we're saying we want 3 of the 4 factors that multiply to equal 81. So what number goes into 81 four times? What time to self, time to self, time to self? 3. We want 3 of those 3's, and that's how we get to 27. Because if you write out, and I'm going to erase this later, so if you're going to write this out, put it someplace else. If you write 3 times 3 times 3 times 3, that's 81. That's all 4 3's, right? We want 3 of the 4, and that's where 27 comes from here. Okay? It's the same thing here. 5 times 5 equals 25. We want one of those 5s, and that's why the answer is 5. That's another way to think about this here. Right? We don't want all 4 3s that equal 81. We want 3 of the 4. And that's 27. Let's take a look at 32 to the 4/5 power here. Okay? Let's look at it this other way first here. What number to the 5th power equals 32? Emmett? 2. So if we have 5 2's, that equals 32. How many of those 2's do we want?
4.
4. So in theory, what should our answer be here?
16.
16. Let's check it. Using this kind of rearranging, 32 becomes the number under the root. The 5 becomes our degree of the root. And we're taking all that to the 4th power. Well, we already said the 5th root of 32 is 2. And 2 to the 4th power equals 16. Okay? So that's what's going on here. We're saying we don't want all 5 2's that make up 32 when you're taking the time itself. We only want 4 of them. 4 of the 5. Right? The next one is an improper fraction. That can happen too. Nothing really changes though. This 27 is still going to be the base of the root. What's the degree of this root going to be?
3.
Still the denominator. Right? So the cubed root of 27 is 3. We're taking that to the 4th power and we get
81.
81. Right?
What are you doing? It's negative.
Yeah.
The next one is the
Yeah.
The negative numerator? No. Who remembers what negative powers mean?
Wait, oh.
Oh,
Negative powers. You know?
you move it to the other part.
Move to the other part of the fraction. We're going to do that last. When you've got a negative power, nothing in the process changes until the very end. We have 125 to the negative 2/3 power. This 125 is still the degree of the root, or sorry, the base of the root. This denominator is still the degree of the root. And we're taking that to the power of the numerator, which happens to be negative. Oh well, it's the negative 2nd power.
What if the denominator is negative?
Okay? Well, remember in a fraction it's interchangeable. So you just move it up to the numerator. So what's the cube root of 125?
5.
5. We're taking 5 to the negative 2nd power,
Then you flip
which
it.
means it's going to become 1 over 5 to the positive 2nd power. That looks like a negative 2 again because I didn't connect my 5. Remember, 5 to the negative 2nd is 1 over 5 to, did it again. Connect the, there you go. Oh, jeez. I'll just write it below. 5, okay. 5 to the negative 2nd is 1 over 5 to the positive 2nd. And 1 over 5 to the positive 2nd is
25.
1/25.
Okay, that makes sense.
And that would be your final answer. So a negative fraction power changes nothing until the very end. You just move that numerator, move that base to the denominator of the fraction. Okay? Give the bottom row a try. I will pause the video. No, this next row. Give the next row a try. I'll pause the video. We'll come back to it, see how we're looking. Sorry, James. This second row, we'll go over it on Monday when this is due for homework. None of you had any specific questions, so we'll assume that things are going at least okay for now. This bottom row here, this should be actually just PO15. You had these rules on your entrance exam. Those rules of exponents and how to simplify. Even with fraction powers, nothing changes. So if we have 12 to the negative half times 12 to the 5 halves, I want you to be able to recognize that, hey, I'm multiplying by the same base here, right? I've got 12 as my base in both expressions. I'm multiplying by the same base. What's the rule for the exponents when you're multiplying by the same base?
You add the.
You add them. So this turns into, what's negative half plus 5 halves?
Okay.
4 halves. And what does 4 halves equal?
2.
2. So we can simplify this expression to be just 12 squared. Which is what? 144. Here's where it all starts to come together now. Those exponent rules that you thought you'd never need to use again, when you get to more complicated calculations, and again, this is like Algebra 2 stuff here, right? So when you get to Algebra 2, you're going to be able to simplify these based on the rules we learned last year in algebra. Okay? When you're multiplying by the same base, those powers get added. Luca?
How do you get 12 squared?
Because I took the powers. My rule when I'm multiplying by the same base is the powers get added. So negative half plus 5 halves equals 4 halves, which is equal to 2. So when I add the powers together, I get 2, which means that this expression simplifies to be 12 squared.
2 12.
So 1 12 is just like make 1 equal. Like the
Well, remember what this is saying? This is saying like, okay, if I had, let's go back to PO15 a little bit. If I had 12 cubed times 12 to the 4th, right? What this is really saying is 12 times itself, right? Times another 12 times itself, times itself, times itself, yes? How many 12s do I have there total? 7. So I would rewrite this to be 12 to the 7th power.
Oh, yeah.
So it doesn't become 112. It's saying how many 12s I have all being multiplied together in total. Same thing here. I've got negative half 12s and 5 halves 12s. Together, that equals 2 12s, or 12 times 12.
How much math are you required to take in high school?
Once you get,
3
I think
years.
pre-calc or calc is your last year. I don't remember what's required.
Yes.
If you start in Algebra 2 as a freshman, I think you'll have to do 2 years. I think.
Yeah,
I think.
okay.
Don't quote me on that.
If you
but I
need,
think.
if you need
Okay,
engineering.
we are almost out of time, so let's do the next one here. Oh, don't put it away yet. Emmett?
Is this homework?
Totally.
I haven't paused it.
I'm gonna let you do that yourself. This next one is 27 to the 1/3 in parentheses to the 4th power. What's our rule when we have parentheses?
Do the math.
Distribute, and what's the operation between the powers?
Multiply.
You multiply. So this gets distributed into the exponents, and what's 1/3 times 4?
4.
Four
Wait,
thirds.
4/3.
4/3. So this becomes 27 to the 4/3 power, and once you have that, it becomes exactly like you did up top,
Okay. So it's.
right? Once we apply the rules of exponents to the expression, it becomes something that we are now becoming familiar with. You'd follow the rules for fractional powers. Next one, 6 to the 9 halves over 6 to the 3 halves. We're dividing by the same base. We have a 6 and a 6. We're dividing by the same base. We can't cancel the bases out. What's the rule for the exponents when you divide by the same base? Gus?
Subtract.
Subtract. So we have 9 halves minus 3 halves. What do we get?
6 halves.
6 halves,
3.
which is equal to
3.
3. And so ultimately we get 6 cubed.
So we do 6 cubed.
And that's going to be your answer.
216.
Okay? Yeah.
For the second one, is 26 4 over 3, is that the answer?
No, you have to simplify that
For the last
further.
one, it's
This
eight
one,
answers.
the second one isn't quite done yet, but now that it's the same as what we did up top, I'm gonna let you finish it. Okay?
For
Emmett?
the last one,
Fourth one, when you cancel the, they have to 0,
Why?
because it's a negative and it counts.
Okay, so we're multiplying by the same base, which just like the first one, means the powers get added. Emmett's pointing out that 1/3 and a 1/3 minus 2/3 equals
0.
0. So we get 8 to the 0 power, which equals 1. Any base of 0 power equals 1. So this is how it all kind of connects. What we did last year, what we're doing it this year, it all kind of connects. Okay, this page is due on Monday for homework. Tomorrow is a retake day. You've got the math packet to work on. Khan Academy's out there as well. But this is going to be
I saw that yet.
due on Monday. That's how you math, folks.